Hi, I'm Anne Blythe Davis from Swan Quarter, and I want to tell you the cold hard facts about aquatic Anuran calling. I designed this project to answer the question, how does ambient water temperature affect winter calling aquatic Anurans? Anurans are frogs and toads. I hypothesized that Anuran calling would decrease or cease below a certain water temperature. This question arose during last year's study when I was testing the effects of night sky brightness on winter calling Anurans. 4.4 degrees Celsius is considered the minimum temperature at which Anurans will call. That's about 40 degrees Fahrenheit. So some of those night air temperatures were well above 4.4 degrees Celsius, but the Anurans weren't calling. So I wondered, could it be the water temperature that was suppressing their calling? The known environmental variables that affect Anuran calling are air temperature, night sky brightness, barometric pressure, relative humidity, and wind speed. But few studies mention water temperature as a potential factor. Male Anurans call to attract mates, ward off other males, and signal distress. Anurans call by squeezing their lungs with their nostrils and mouths shut. Air blows over their vocal cords and into their vocal sacs. The sacs inflate, vibrate, and resonate the sound. 4 species of aquatic Anurans call in eastern North Carolina during the winter: Brimley's coarse frog, the southern leopard frog, the little grass frog, and the southern cricket frog. Here's the little grass frog's call. And here's the southern cricket frogs. Anurans are poikilothermic. They're also ectothermic. Their body functions depend on enzyme molecules moving through cell membranes at a certain rate. The permeability of the cell membrane varies with temperature. As temperature rises, permeability increases. If the temperature gets too low, the cell membrane will become impermeable and the enzymes will be unable to get through. Thus, the function depending on them getting through will cease. In temperate climates such as eastern North Carolina, some aquatic Anurans reproduce during the winter. Their body temperatures are near water or immersed substrate temperatures, so it seems likely that certain body functions, like calling, will correspond with water temperature fluctuations. Water temperature changes lag behind air temperature changes. Why? Because of specific heat. Specific heat is the amount of heat required to change 1 gram of substance by 1 degree Celsius. The higher the specific heat, the more heat needed to change the substance's temperature. Substances with high specific heat retain heat longer than those with lower ones. Water specific heat is about 4 times that of air, so it retains heat a lot longer than air will. Because water heats and cools more slowly than air, there is a lag time between the two. After several days of cold air temperatures, water temperature will drop, and it will not rewarm as quickly as the air temperature will. If several days of cold air temperatures cause frog ponds to cool, when the air temperature warms, the water temperature will not rewarm immediately. Thus, I think that on some nights with favorable air temperatures for calling, I will not hear Anurans because the water temperature isn't warm enough yet. This project, my independent variable was water temperature, my dependent variable was Anuran calling, my extraneous variables were other meteorological conditions, and my constant was the fact that I used the same 3 stations throughout the study. I used a variety of basic materials, including 3 marsh locations, a data sheet, and a few thermometers. Before I began collecting data, I brushed up on my frog calls and habitats. I also read some about frog physiology and water heat retention. My 3 data collection sites were located near Mattamuskeet National Wildlife Refuge, a few miles from my house. I had 3 sites for the sake of replication. My data collection sites were shallow wetlands with grassy edges. Here's data collection site number 2, complete with an Anuran eater, the gray egret. And here's data collection site number 3. Wanted to vary the times I went at night to avoid bias in my study. 1 would represent 1 hour after sunset, 2 2 hours, and 3 3 hours. I told a random number generator at stattruck.com to produce 15 sets of the numbers 1, 2, and 3 in random order. I had 15 sets because at the beginning of my study, I didn't know how many nights I'd be able to go out, so once I finished those 15, I just started over again. So, 1 to 3 hours after sunset, I went out to listen for Anurans. At each site, I took the water temperature at the surface and the substrate. I did it at both the surface and the substrate because some Anurans call from the surface and others from the substrate. Then I listened for Anurans for 2 minutes. I recorded what I heard using the Anuran call index. 1 was 1 individual heard, 2 overlapping calls, and 3 a full chorus. I recorded all of this in my data sheet. This chart shows a summary of my data. I collected data on 26 nights from November 30th to February 11th, and 2 of the 4 aquatic Anuran species I expected to hear were heard, the Brimley's coarse frog and the southern leopard frog. Water surface temperatures range from 0 to 16.8 degrees Celsius. More than half were 7.7 to 9.8 degrees Celsius, and a bit over 15% were freezing, or just above freezing. The substrate temperatures followed a similar pattern. Temperatures ranged from negative 4.4 to 19.4 degrees Celsius. Most of the time, water temperatures were greater than air temperatures. This year's winter air temperatures were cold. This chart shows the average winter air temperatures for the winter of 2010 through 2011 and the winters of 1971 through 2000. On average, this year's winter and fall air temperatures were about 13 degrees colder than those for 1971 through 2000. So the southern leopard frog call index total was 38, and the Brimley's coarse frog call index total was 3. And all but one of these call records were heard at or above surface and substrate temperatures of 8.9 degrees Celsius. This chart shows calling phenology. Phenology is the time of year at which a behavior occurs. The red line represents the calling time designated by the Calling Amphibian Survey Program, the green what I found in another study last year, and the blue this year. The southern cricket frog normally would have called throughout December and February, but I didn't hear it at all in the study, and the same goes for the little grass frog. Brimley's coarse frog should have called throughout December and February, but it only called once at the end of November and once at the beginning of February. The southern leopard frog normally would have called throughout the entire study period, but I didn't start hearing it until February 2nd. The southern leopard frog did not call until February 2nd, which is 6 weeks after the normal call dates known for its species. On that day, surface and substrate temperatures had increased by 4 degrees Celsius to 14.7 and 14.4 degrees respectively. I first heard the Brimley's coarse frog on November 30th. I didn't hear it again until February 8th. Normally it would call throughout December and January. This chart shows Anurans heard compared to air temperatures. I had 19 total nights with suitable air temperatures for calling, but I only heard Anurans on 8 of those nights. This is probably because on the other 11 nights, air temperatures had recently warmed up, but the water temperatures were still cold. Notice that I did have one southern leopard frog call in a night with temperatures less than 4.4 degrees Celsius. In fact, it was negative 0.6 degrees Celsius. This is probably because air temperatures and water temperatures had been fairly warm until air temperatures dropped, but water temperatures were still warm. Based on previous data, Aquatic Anurans should have called throughout December and January, but their calling was delayed until February 2nd when water temperatures spiked. The water temperatures were affected by unusually cold air temperatures. The results support my hypothesis that at or below a certain water temperature, Anuran calling will decrease or cease, and the temperature at which they ceased calling was 8.9 degrees Celsius, about 48 degrees Fahrenheit. 11 nights had adequate air temperatures for calling, but no Anurans vocalized. Thus, a variable other than just air temperature must have been suppressing their calling. Because their calling began when water temperature was 4 degrees in a day, it's possible that that temperature spike caused cell membranes to become more permeable, thus allowing certain enzymes through that affect calling. The southern leopard frog was the first frog to course. It began calling on February 2nd. This species size, almost twice that of Brimley's coarse frog, could have resulted in comparatively more heat retention. That's an example of Bergmann's rule. Larger body size results in higher body mass to surface area ratio. Anuran calling began when surface temperatures reached 14.7 degrees Celsius. Anurans continued to call until water temperatures dropped below 8.9 degrees Celsius. This chart pretty much summarizes my data. It's Anuran calling compared with water and air temperatures. Pay attention to the purple line. That's Anuran call index. Then notice the lag between air temperature and water temperature. Then notice the lag between water temperature and Anuran calling. Notice that Anuran calling more closely follows water temperature than it does air temperature. This supports my hypothesis. So does it really matter that a water temperature affects winter calling aquatic Anurans? Yes. The data from this study could be used to improve North Carolina Calling Amphibian Survey Program, CASP survey protocol. Right now, CASP has no criterion for water temperature, but if they did, it would have a better chance of hearing aquatic Anurans on the nights they went out. This could also be used to optimize detection of species in other studies. It could also be used to understand calling patterns in artificial wetlands that have water inflows of various temperatures. This project sparked some new questions. I collected the data during an unusually cold winter. Would I have had different results during a warmer winter? Would I have different results during another season? Does a delayed breeding season like this one extend later into the year? How does delayed egg laying affect species that eat Anuran eggs and tadpoles, like herons and fish? I'd like to thank Nancy Bray for support throughout the project, Jeff Hall and Mike Dunn for supplying me with photographs, Jerry Fringley for letting me use the Refuge After Dark, and Dr. Michael Dorcas for letting me use his Anuran recordings. I used a variety of sources, including journals, books, and websites. Any questions?